Hello, everybody. My name is Stephen Feuerstein, here for another Ask Tom office hours session on PL SQL. Thanks for joining us. I have with me Chris Saxon, my developer advocate team member, who often assists me in making sure that when we answer non-PL SQL questions, we can get answers, of course, with PL SQL as well. And our special guest, Shashank Barki, who I will introduce in just a moment. So in my continuing tradition of not only wanting to share what expertise I've got, but also get expertise from around the world and share with you, I have another guest to talk about our topic today. Now, let's see. What I'm going to do is share my screen. Go over to Live SQL for just a moment. Not Live SQL, sorry. Go over to Ask Tom. So you're here, I assume, by clicking on this page and joining our session. So Ask Tom Office Hours is a special program in which we offer literally dozens, I think we're over 25 different sessions each month from Oracle database experts, mostly at Oracle, but sometimes, as you'll find today, from outside of Oracle as well, to help you get the most out of Oracle database. Now, in terms of the Ask Tom Office Hours page, obviously you can join the session, which you've done. We'd also love it if you take some time after the session is over, or even during it, to give us feedback on the session. How useful was it? Any suggestions for next time, including future topics? You can also ask a question of us right here on this page. This is not meant to be a replacement for Ask Tom and the real full-blown Q&A, but you can pass as a quick question, which we'll hopefully use in a future session, answer as well, and sometimes publish in Ask Tom. And you should sign in and subscribe. I've already subscribed, so that you get monthly reminders about our upcoming sessions. Okay. So today, we're going to take a look at how to find slow PL SQL. This follows on Chris Saxon's session last month, or that's right, it's last month now, on finding slow SQL. And the focus will be on the PL SQL profilers, and we'll be hearing from Shashank Barki. So first of all, just some general comments or perspectives on finding your slow PL SQL. First of all, PL SQL gives you lots of features to help you optimize performance of your code. Automatic optimization that started way back in Oracle 10G, so you write your code however you like to, and the PL SQL compiler will figure out ways to make it run faster automatically. Pragma UDF for improving performance of calling your functions in SQL. Bulk processing for all and bulk collect the function result cache. Lots and lots of features. And some of these features are things you should apply upfront proactively. For example, bulk processing is often a good thing to build into the design from the start. But what you generally don't want to do is get overly obsessed about optimizing and thinking, I'm going to make sure that every single line of code follows every single optimization tip I can think of. So for example, I'm not going to use integer, I'm going to use PLS integer. And maybe in some cases you'd see a benefit from that. But obsessing too much about optimization up front can often slow down your development with no real benefits to your users, because it doesn't matter about whether or not you make your application as fast as possible. What matters is that you make it fast enough for user satisfaction. So in general, a good path to follow is focus on obviously implementing your functionality correctly, focus on testing it, focus on making sure that your code is maintainable, and of course, build in obvious performance optimizations, and then test your application, test it in terms of stress testing, and of course, we end up testing it in production too. Find out where your bottlenecks are, and then you'll optimize in those bottlenecks to really get the best productivity performance ratio for your work. Now, in terms of figuring out where the parts of your code are running slowly, obviously your users will tell you that to some extent on a kind of macro level, but you often need to drill down from there. And that's where our PL SQL profilers will help you get this job done. So there are two different profiles. Don't worry, Shashank. You're going to go into the details on it. I'm just doing the very high level coverage. So there are two different profilers for you. One is called DBMS Profiler. It's been around, I think, since Oracle 9. And that basically allows you to track the time taken for each individual line of code executed, which is great. Tons of detail, tons of data. Shashank's going to go over that with you. And then I believe in 11G, we added DBMS HProf, which is the hierarchical profiler. And the idea there is to give you more of a higher level view of where your performance bottlenecks are by focusing on subprogram performance, not the individual lines within them. So they complement each other. Now, I could show you the basics about Profiler, and Chris could show you a bunch more as well. But I like to go, but I don't have much more than a sort of abstract experience with profilers. What I thought I would do is invite someone who's out there in the real world, dealing with real world problems, to talk about his or her experience with profilers. I put out an invitation on Twitter, and Shashank got in touch with me. And so I'm very happy to welcome Shashank Barki, who's a senior principal data engineer for Manhattan Associates, to share his experiences with profilers. He's had 13 years experience as a developer, cloud architect, data analyst, but in every one of those jobs, he assures me, he has worked really hard to promote the use of PL SQL and to focus on performance, security, and maintainability. And out of that, he's had this experience with profilers. So Shashank, what I'm gonna do is stop sharing so that you can share. I'm gonna turn off my camera, so we'll just focus on you. And sorry, I should have also mentioned everybody that within Zoom, you can use the chat box to type in messages to us, but more importantly, use the Q&A box. You can ask questions, we'll answer them. I'll address them to Shashank. Chris and I can both be answering them as we go through the session. Alrighty, so I'm gonna stop my video and hand it over to Shashank. Thank you, Shashank, for joining us and sharing your expertise.
Thanks, Stephen. I have shared my screen. Just let me know if it's visible.
It is visible, yep.
Okay. So good morning, good evening to everyone. First of all, thanks, Stephen, for this opportunity. It was nice talking to you, and I have been working with PL SQL right from the day I started, my career as an IT engineer. So it's a kind of good opportunity for me to share what I use very regularly to the PL SQL community. And this is one way of me sharing my knowledge back to the community. Thanks to Tom Kite, Chris, yourself, because we use your blogs and your videos to learn a lot of things. So I think having an opportunity to present something like this is a kind of dream come true for me. I hope there are certain takeaways for all the participants over here, and I hope that they get some benefit. You can always reach me and maybe through my Twitter handle if you want to know a little bit more, since it will be a kind of a limited session. So without taking much time, I'll start off. So like Stephen introduced, I work for a company called Manhattan Associates. I have been working there as a principal data engineer. I have been working as a developer, a cloud architect, as well as a data analyst. And my first choice of programming always happens to be PL SQL. That is the one which kind of gave me as an opportunity to explore how computers and programs in general behave, right? So I have been kind of involved with PL SQL from very long time. So when we talk about code, the first thing which comes to our mind is obviously the performance of the code, right? So we always have the code, we always have things ready for performance. Everything looks rosy. Then you put the code into production, and that is where the fun starts, right? So how do we kind of go and debug these kind of issues, right? So each and every programming language comes up with its own kind of debugging and performance related tools. There are also third-party tools available which help in kind of narrowing down the issue. But when it comes to PL SQL, so PL SQL is all about procedures, packages, triggers, functions, isn't it? So these are all the major programming constructs we have, right? So when we have PL SQL program, when we have a performance bottleneck, so what do we do? Right? This is the whole idea. And how do we drill down the issues, right? So the agenda for the session is to just understand PL SQL performance at a high level, and then deep dive into the profilers, which Stephen also talked about. So when I talk about any code performance, right? So what are all the pointers we look for, right? So there are like 6-7 kind of categories I could come up with, right? So whenever you are given a particular code or particular slow running code, right? So what are all the things you look for? So obviously you want to understand the flow of the code. What is the purpose? What is the functionality? What is the idea behind this? So that is at the high level, right? So once you know the code flow, you obviously try to understand whether there are any iterations, right? Is it looping? Is it having right kind of bulk collect options, right? And then you see how many times it is kind of executing. Is it executing once in a loop, or is it committing in the right kind of way? And you always are kind of encouraged to use bulk operations, use for all, wherever it's possible. And there are certain scenarios where you would have nested calls, right? So you would have a calling package, which in turn calls another procedure for certain activity. It returns certain values, and again it calls another value which is passed as part of it. And it could be having multiple nested calls. So when you're given a code, a production code which you didn't develop, but you are asked to kind of debug and give where is the bottleneck in this particular code, what do you do? Obviously, if you are working in Oracle world, right, one report which everybody uses is the AWR report, right? So we always generate the AWR reports and try to understand what's going on. But then again, AWR report is from the database and database performance standpoint, it will not give you the kind of exact information you need from the procedure code perspective, right? It might tell you this particular stored procedure is slow, or it might be CPU intensive and things like that. But again, if you want to understand the entire PL SQL code performance, you have to reach for something which I talk about now. So there is something called as a PL SQL profiler. Like Stephen has mentioned, it's been around from I think Oracle 9. So it's kind of been there from long time. But I don't know, like the advantages this provide is really amazing, right? So this is one particular tool which I use very regularly as part of my day-to-day job, right? So what happens, I work for a retail company. So it's an OLTP application, right? So we deal with records which are in millions, right? So multiple millions. So what happens, we have OLTP, we have right kind of third normal form data, we have right kind of indexes. This is what is the general data model, right? Which is kind of done in the right way. But then again, performance is something which always comes and hits us when users start using the system extensively. So we have, like I said, a lot of code which is in OLTP, and we have a lot of stored procedures, packages, and they're all data intensive, right? So you have tables which have multiples of millions of records, and you kind of try to write a code and retrieve certain specific data for a functionality which we are trying to perform. There is always a chance that this kind of code might break or perform slow, and that is a scenario we face very regularly, right? So I can give you a couple of examples, right? And once we get into the code, I'll try to give little more information on that. See, just imagine that you have a kind of a store, right? In a retail world, if I want to make it very simplified. So we have a lot of inventory which comes into the store, right? So you get the data from the warehouse, or it could be from the vendor. So now whatever data you're getting, you're, let's say, having it in some kind of tables, right? So now you have certain functionality which kind of gets certain data, and it has to aggregate some things and give it as an output to the front end. Let's say it's a Java front end, or it could be .NET, right? So, and the back end, of course, is Oracle stored procedures or packages which we have to retrieve the data. So now this is the scenario we work on, right? Usually we work with, like I said, millions of data, and all of these are all driven by these performance heavy packages and stored procedures. So when given a problem statement to kind of understand where this particular PL SQL is taking time, you have to always use profilers. So at a high level, right, let me tell you what exactly profiler does, right? It obviously collects data, right? So if you want to understand the code, right, see, you might not know the functionality, right? Each time you might be called for debugging a performance issue, right? So you might be asked to give information on specific areas in the code which is taking more time, or it could be something which might be in one specific piece of code which might be taking time. Let's say you have, okay, you can always argue and tell me, hey, why not I use AWR? Like I said, AWR will give you slow learning sequels in that particular database, right? And there is a chance that this particular piece of PL SQL code might come or might not come. If the overall performance of the database in other modules was slower than what we are looking at, obviously AWR might not be able to capture that. It might capture top 10 rows and all, right? So now in this scenario, you have to kind of go for PL SQL profiling. So like I said, it gives granular information on the total number of times each line executed, the total amount of time spent on that particular line, and the maximum and minimum time spent on that execution. So this is a kind of granular information you can kind of even imagine in any given code. And moving on, where these particular things are stored. So we have certain database tables, intrinsic tables, which stores this information. And once you get this information stored into the table, you can get some report called a profiler report, right? So this is one which is like an HTML report, which gives all the information for you for further analysis. So this is about profiler. I'll go back and show you a demo of this particular profiler. Now that you know, like where is the bottleneck, where is this particular code taking time, which line of the code is taking time. So you might ask me, what if there is a nested scenario, right, where there is one particular stored procedure or a package at a high level, right, which in turn calls some more procedures and packages. It could be complicated application, right? Like I said, you might be dealing with multiple tables, functionalities might be crossing over. So input of one data, right, output of one could be going in as an input to another procedure, and it could be nested. So in this scenario, how can I kind of get more information so that I will be able to debug it even better and try to understand the performance bottleneck? So that is where we have something called as hierarchical profiler. So this, as the name suggests, right, it's about the hierarchical way it kind of drills the data and gives in form of reports. So, and another advantage here, right, which we don't get in profiler, this will kind of organize it by functional calls, and it also reports your SQL and PL SQL execution times separately. So you need to understand that in a PL SQL world, we have something called a SQL engine, we have a PL SQL engine, and you have something called context switching. You want to reduce that. So that is where you have all these PL SQL performance bottlenecks, right? So we want to use the bulk, we want to use for all, we don't want to switch between SQL and PL SQL execution engines very often, because it might have an overall impact on the performance of the code. So now with hierarchical profiler, we get that also separated out, right? And any particular PL SQL package or a procedure can be profiled. So now you have a hierarchical profiler. So this also generates HTML output the way we have for a profiler. This has more granular information, like the number of calls to the subprogram, the time spent in the subprogram, and the time spent in the subprogram and its descendant subprograms, right? So this will be like a parent, child, grandchild information, right? So if you are calling a subprogram in the calling program and you want to know where exactly is the bottleneck, you can use hierarchical profiler, and it gives you more information on that. So here again, there are two components, right? When we talk about HProf package, so we have something called as a data collection part of it, and then we have analyzer part. So data collection part is again something which is intrinsic to the PL SQL virtual machine, right? So you have the data collected when you call the DBMS, and once you have the data ready, you always run this profiler output to get the results in HTML format. So this is about the hierarchical profiler. So this is like a sample output I'm showing. Anyways, we will go back and look at a couple of examples. So this is how a profiler output looks for you. Here you can see certain procedure calls in the second line, right? So you can see the profiler calls the libraries, and it shows the top 100 profiled source lines, right? So it shows how many number of times this particular query executed, what was the minimum and maximum time, right? So you get all this information, and it even gives the procedure name and the line as well. This is a sample profiler output, and this is one of the sample hierarchical profiler output. So here you have one big report, right, which says what all the information you can drill down and read, right? You can get the function elapsed time sorted by the function. It could be something by the module. It could be something sorted by the elapsed time of parents and children which are involved, which is nothing but the calling and the subprograms, which we'll be talking about. We'll be going back and looking at this example. And there are certain resources which we have, which you can refer to. There is a meta link note as well. We'll be publishing after this particular session. And this is about the PPT, right? I wanted to keep it short so that we can kind of go back and see some kind of hands-on session. So I have a SQL developer opened. So this scenario, right? Now there is a scenario, right, where like we have a calling stored procedure, right, which was taking time. So now this particular stored procedure wanted some kind of boosters, right? Like we were not understanding where it was taking time, right? So this is something which you face if you are part of database performance teams, right? So you get ad hoc requests where you don't necessarily understand the functional part of it, right? Why this particular code is in this place, right? But people need some kind of ready-made or readily available solution. So they want you to narrow down the issue or give them more inputs on like where exactly it is taking time. So there was a scenario which is a classic scenario which I faced some time back, right? Where there is one procedure which was a custom procedure. So usually what happens in your programming world is you have base program. I think usually the R&D teams develop this, right, as part of the product. So then on top of this, we write something called as custom programs, right, which are all customized for a specific customer, or it could be related to some module itself, right? So these custom programs usually could be written from non-PL SQL folks also, right? That is also a common scenario in IT these days, right? People are doing cross programming and people are involved in multiple roles. They'll be, it's like something like I might be from PL SQL background, but I go and write some Java code. So there is always a chance that I might miss certain best practices, or I might miss a lot of things over there, right? So this is the scenario where we had certain code written by a functional team, right? So they kind of constructed a code and they came back after maybe about a month. They claimed that they had done unit testing and functional testing. I don't know whether what kind of performance testing was done, but they came back and told us that this particular stored procedure had bottlenecks, and they had certain subprograms called as well as part of it. So now this is where this was a classic scenario which I could use for profiling. So let me yeah. Before I go there, right? If in case you want to know like how do I find of even set up the profiler, right? If in case you have a database system, you have a command line, you have a SQL developer, you want to first set up the profiler, right, to be kind of available for you for running actual profiling part of it. So we have something you can always log in as a system, right? I mean, even you will get the entire set of steps and all as part of the link I'll share. But at a high level, let me explain very quickly. So you log in as a system user, and you log into the Oracle Home RDBMS admin, and you kind of run a particular SQL file. So what this does is it's going to create certain tables, like I said, which will be kind of holding the profiler related data, right? So now this is the actual step we perform. So what we do here is, like I said, this is the part which starts the profiler, right? So we use something called as a run ID, right? Run ID is like it could be like a primary key, right? So we will be feeding this run ID to get the further output, right? So, and this is where we call the stored procedure, or it could be a package as well. And once we get this information, this will actually execute the stored procedure also in the backend. If you look at it, right, you are calling your procedure. So when you call your procedure, obviously it is something which executes in the backend. So in the meanwhile, when the stored procedure is being run, you have run the start profiler, which is capturing the information which is needed for you. And once you stop it, right, you have the information ready to kind of generate something called as a HTML report. So what better report than a HTML report, right? When you are analyzing it, it's very easy to read. Even AWS, like you see, we prefer generating in HTML format. So now I have this piece ready. I'm going to execute this in SQL Developer. I have already set up the profiler now. Yeah, so this is my piece of code. And the beauty of it is like you can use SQL Developer to run it. You need to ensure that you have given the DBMS profiler privilege for the existing schema, right? So this is the stored procedure call, and this is the schema prefix. This is not a mandatory thing, but I am going to use this. So now what's happening is it's executing the stored procedure with the profiler switched on in the background, right? So now the stored procedure execution, let's say, might take about a minute or so in this scenario. So now once this gets completed, we can go back, run the profiler part of it, generate a HTML file, and try to analyze how to understand the profiler data. So let me just switch back to the other screen. This is the one I was explaining to you. So once we complete this part, right, which actually runs the stored procedure, we have to go back to the command prompt, right, and we log in using this user whatever we have used, right, as a schema, and we have to run the SQL profiler.sql. So this is the one which prompts for the run ID. Yeah, this is a stored procedure which has taken about which was taking about a minute. Yeah, see, it says about 68 seconds it took for the total execution. Now, if I
done,
look at
Shashank.
it, right?
Well done. Time that nicely.
So if you look at it, right, if I had to kind of get more information on this stored procedure, what is the obvious way you can think of, right? Some people suggest have a lot of DBMS output statements, right? So, okay, yeah, agreed. Maybe if somebody is very new to the programming, he might kind of add certain logging. But again, that is not something we want to do, right? Logging should be added wherever needed, right? It need not be added at each and every piece of code, right? So we cannot add maybe 50 or 100 DBMS output, right? It is not, if you ask me, it is something which is not needed. So now profiler is something which hopefully does that heavy lifting for us and gives the right information. So now that we have run it, I'll go to the second part of it. Yeah, so this is the piece of it where I have the profiler SQL, which I was talking about, the second part. So here we log into the schema and we execute start profiler. Yeah, like I said, it will prompt me for a run ID, right? Run ID is like a running number, right? So in this case, it is 13 for me. So once I execute the run ID, it's gonna run the profiler output for me in the backend, and it's gonna show me, it's gonna create certain HTML files. Yeah, so it has completed. So let me exit here. So this is the profiler, right? Profiler 13 is the run ID we gave. It usually kind of suffixes it with the number which happens to be the run ID. So once we have the HTML output, next step is obviously to kind of go back and analyze it, right? So for that, usually we use some kind of yeah, here we go. This is the output. So this is the profiler output, right? So like I said, this was a one stored procedure which in turn had calls to another two set of procedures, right? So if you look at it, it's very clear, right? The output of it, if you look at it, it shows the profile, the PL SQL libraries, like that there are three procedures which were called. how much this particular stored procedure took. It took 65 seconds. So we know, if I look at this at a high level, right, immediately I can tell that this particular stored procedure had an issue, not the calling procedures, right? So now this gives me information from the stored procedure execution and the number of times this particular stored procedure took standpoint. We will try to drill a little bit down, right, and understand how to read this output. So now I understand that there is no issue with this C update 204 and C update item attribute, but there is some issue with C update 185. This is the stored procedure name. So in the first glance itself, I know there is some issue. That's the beauty of it, right? Now, if I want to kind of drill down and understand how to kind of get more information from this file, see, there is one line on top of it, right? So this shows that this particular statement, update orders or something, right, ran 100 times, right? 100 times it ran, and it took anywhere between 0.61 seconds to 0.67 seconds. So just imagine, right? So that clearly tells there is some kind of an update which was done in a loop. So that tells that there is a scope for us to see whether we need to even do that way, right? Do we need to update in a loop, and do we need to loop through 100 times? So that is an obvious piece of code which kind of warrants some kind of further analysis, right? And if you want to understand the second piece of it, it says 1.85 seconds this particular piece of code has taken, which happens to be something like select count of one from a table into a variable. So this is the second level of information I get immediately after looking at the output, right? So now I can immediately tell someone that, hey, there is some problem here which might probably have some scope to go and modify, right, or correct. And there are two pieces of information already available for me. So now if I want to understand the code even in further depth, I have the entire code available here in that unit 2. It comes from the all source, if you are aware of user source, all source and all, right? So which gives the entire piece of code. So this gives me, if you look at it, right, total time taken per line kind of thing. Just imagine getting this kind of information, right? The beauty of it is like it's so self-explanatory, right? I look at it, stored procedure line number, I know that it has executed once or how many number of times, right? And what is the total time taken? So look at this, there is a loop here, right? So, and it says that this particular piece of code has run 100 times. So have they run the right way? Are they doing the particular piece of code they have kind of claimed in the right way is the next question we need to ask, right? So once we get this information, we can always go back and either change the code, refactor it, or suggest certain things, right? So if you look at it, there is another observation. The commit is done inside the loop. So these are all the things which we can immediately point out and avoid, right? So you might not have time forever to kind of give changes here or recommend changes, but these are all things which can immediately be implemented, right? And if you want to further narrow down, say there is another loop here, and I think this is where it took the bulk of time, right? 62 seconds. So now you know that this particular query has run 100 times, right? And it has taken about maybe 0.6 seconds per execution, which probably can be kind of avoided. So this is the information you have, and you again see commit which was done in a loop, which probably is something which they should not be doing, right? And there is another statement which took about 1 minute and 85 seconds, and there is some kind of scope, right? So usually, right, it depends on the SLA, right? So this particular stored procedure SLA might probably have been defined when we have the code put in production, right? It could be 1 minute, or sometimes it could be 5 seconds. So when we kind of don't meet the SLA, this is where we kind of always go back to the profilers and hierarchical profilers to kind of drill the data, right, and try to understand where we are kind of taking maximum amount of time. In my experience, right, with PL SQL and in general programming, right, if you look at an entire set of stored procedure or a package, usually, right, there will be certain culprits, right, certain pieces of code which contribute to the maximum time taken. It's very rare that the entire stored procedure or an entire package is written badly, unless it's written by either a novice or someone who has probably not done programming, right? But usually that will not be production ready code, right? In general, what happens is we get code which is there in production, but it will have certain pieces of certain pieces in the code itself which will be written either poorly, or there will be scope to kind of refactor the way it's written. So now that is where this profiling output helps me, right? So now if you want to understand further, right, see there is another call to the stored procedure. So you get the entire information, like that particular stored procedure, what was the total time, how many times this particular stored procedure was called, right? So it's very self-explanatory, right? I did not explain everything over here. Yeah, and there is another loop here. Yes, it has taken about a second, right? It has executed twice. So was there any need to run this twice? That is the next question, right? So it could be a variable they might be using from a cursor. Probably it kind of increments and they want to run a couple of times, right? But in most information is very helpful. And there will be pieces of code which will be written either with looping, right? So there might be some unnecessary loops. They might not be using for alls, or they might be writing certain code which has calls to programs which probably won't make much sense in a bigger picture, right? So these are all the things we can immediately catch. Entire code which comes, right? And I mean, if you want to remember one thing about profiler, right, after the session, just that could be something like it gives you information on the number of times this particular piece of code executes and time it takes. But if you look at it in a big way, right, these are the only two things we need, isn't it? So you want to know which piece of code is taking time and how many number of times it has executed. So I couldn't have asked for a better output than this, right? So if I were to pass on this HTML output to anyone from the team, right, or from the programming background, he'll be able to pinpoint and tell, hey, this is the exact issue we are facing. You go back and see why you are executing this piece of code 100 times. Is there something wrong in the way the programmer understood, or the functionality itself needs kind of refactoring? And this is a complete information. So this is about the SQL profiler part of it. And there is always a meta link, like I mentioned, which gives you more information on how to run this, how to set up the entire profiler part of it. And I'll be working with Steven, and we'll share the links, right, useful links, as part of maybe after the end of this session.
Excellent. Hey, so Shashank, why don't we take a moment to just go through some of the questions that have come up? And I think I've got answers for them, so there may not be anything, but why don't I tell you what I answered, and you can tell me if there's anything I missed. So first of all, is there any additional cost or licensing issues with the profilers? No, it comes with PL SQL, all additions of the database, no additional fees or licensing needed. We all agree on that. Excellent. Does it need DBA or system privileges? So my understanding, Shashank, and you correct me if I'm wrong, is that a DBA may need to grant execute on the profiler packages if that's not already been made available. And a DBA or someone with DBA authority will need to be able to create a directory in the database so that you can output the HTML files. But I think beyond that, no DBA privileges are needed. What do you think? Would you agree?
Yeah, absolutely, Stephen. That is the right thing, right? So we need to have a privilege for these particular packages, right? DBMS underscore profiler or DBMS underscore hprof, right? This particular packages we need to have an execute privilege. So there is no need for the schema which is trying to use the profiler, right, to be a DBA. There is no need for that. So application schemas can use the profiler as long as they have the right privilege. I agree with you.
I just add as well, from 19C, they've actually removed the directory implementation. So it now all writes to database tables. So you only need access to execute DBMS hprof. So I think they added that in 18, and they removed the old way in 19. So
turns out that writing to files in the cloud was not a great idea.
Yeah, writing files is always a bit crazy anyway, I think.
Especially in the database.
Exactly.
Okay. And we had a question about using Oracle Apex debug. You can see an output of all calls executed and its time. Is that feature using internally the profiler, or is it included by default when using Apex? So my understanding is that Apex debug feature, which is really great, is not using DBMS profiler. It's doing its own tracing and tracking of times. So I don't believe that there's any intersection of the functionality there. And Kevin raised a number of points or concerns about using performance analysis tools in the database that often require database DBA privileges, which is a real bummer for developers who have to bother their DBAs. So hopefully you see that we're kind of moving in the right direction. We're removing the requirement around a directory output in 19C, and it's simply a grant execute on the package, which is just done once, and then everybody can theoretically use it. So hopefully, at least for these profilers, it's not too inaccessible for developers. Let's see, do we get some more? Which version of Oracle will this be available? These profilers have been available for many versions. Everything Shashank is showing you, available now. The only difference, as Chris pointed out, is that in 19C, you will not be able to or have to write out to a file anymore with the DBMS HProf package. Okay, let's see, we'll give this one to Shashank. How do we know the amount of time executed is just because of problematic SQL or some other process causing it, like say some other DML blocking?
See, DML, to answer that question, right? Yeah, that is possible, right? Like there could always be locks in a database schema, right? So there might be some kind of DMLs which are crisscrossing, right? They might have run certain things, but here, right, the idea is not to get the locking information per se, right? So locking information will be available in your DBA blockers or $lock, logged object, these kind of tables, right? So now there is a possibility that there might be some locks, but what the developers need to understand is when there are things happening in the production, the first point for them should be to go to AWR, right? So AWR will give an overall picture. But now once you get AWR report, you see there are certain maybe procedure calls. There could be certain things which they are not able to drill down and understand from program per se. That is where we go back to the SQL profiler part of it. So there is a possibility that, yeah, there might be certain locks in the system, but locks would be like something which cannot be found out using an utility like a profiler. That is not meant for it.
I think that's the point, is that the profiler is the start of the analysis. The profiler tells you where to look. So you might have identified that this one procedure is taking an enormous amount of time. It doesn't tell you why exactly. It could be a block on a row, a lock. It could be something else in your code. That's where you start the exploration. And here's another question from Kevin. Is it possible for the output of PL SQL Profiler to generate a diagram to show me the performance bottleneck? Diagrams are so easy to understand. And I will say this, sure, you can write you can take this data and generate whatever HTML you want, but I don't believe that we provide that for you at this time.
Yeah. See, I think if I have to add something more on top of that, right, Stephen, if I have to diagrammatically show this, since we are kind of narrowing down line by line per se, right? So having a program, it might look like, like a, I don't know, it might have too many things to display diagrammatically. It might not be the right way to display it, right? If in case it would be more of showing if there were certain tables, and if you want to show third normal form or how they are kind of related to each other, we can do that. But when we are showing the code itself is a program, if you ask me, right? Sorry, code itself is a diagram, if you ask me. So it's something which is in back of each developer's mind. So how he has kind of envisioned it, how he has brought it programmatically, it's a diagram in itself, right? So if I want to kind of show another diagram, I don't know whether it's going to be the right use case to use the PL SQL profiler.
And here's another question. You mentioned the total time maximum is a key indicator to identify a bottleneck. Can you please give us an idea of common performance issues? Any book or resource you would recommend?
Yeah, if you want to.
That's a big question.
So it's very simple answer, right? I mean, this is something I'm using all along, and whoever is part of this probably would know where to reach out if you have PL SQL issues and all. That is Stephen's blogs, Stephen's book, PL SQL per se, right? And always we refer Tom Kite's site because Tom Kite's site is like the Bible, right? So there's so much information. I'll tell you, I've seen this website from so many years. And I have also posted myself a lot of questions when Tom Kite was answering, right?
Mm-hmm.
There is so much information available. So if you want to know more about the SQL or PL SQL part of it, we can always reach Tom Kite website, right? So that is something, I think there's a blog as well. So you get a lot of information, a lot of questions are answered, right? So that is one place I would say, right? If you want to get more information. But in at a broader way, right? If I have to tell, if I have to give you some kind of tips on performance tuning, right? From PL SQL procedure or package point of view, it's like there are few only, right? Here you always try to avoid looping as much as possible because looping is costly. And if it's a SQL, always ensure that merge Cartesian joins are completely avoided. It's third normalized form, right? So that is something which is really important, I'll tell you, because I can give you a very simple or not a simple, a complicated scenario which I faced a couple of days back, where there are, just imagine like there were 3 tables in a SQL which with right kind of where conditions, right? So now with this particular PL SQL, SQL, there were 2 tables joined and the third table was not joined, right? This table had only 5 records. Just imagine, when I got the explain plan from there, the merge Cartesian join, I knew that there is something wrong, but the amount of time it took to execute that was about 114 seconds. Even though there were 5 records in that particular table, the merge Cartesian join makes our cost optimizer go crazy. I mean, this is my kind of observation and experience. I think maybe Chris might be the right person to add more on top of that. That
Chris,
is
do you want
something
to
which we need to avoid.
Some suggestions around performance? I think you
I
might
think
have some ideas.
Yeah, I think the main thing is just find out what particular thing is slowest, because there's almost an unlimited number of things that could go wrong. You know, you might have made a mistake in your query. There might be missing some indexes. You might have blocking sessions. There might be a hardware problem. You know, maybe your disks are completely toast and really slow for some reason. The thing is to just narrow down very quickly on what the slow component is, and then you can start doing diagnostics on it. You know, if it's SQL statement, looking at the execution plan, reviewing that, and just kind of drilling further and further till you can say, this is the thing that is causing the slowness, and then start analyzing, well, why is it slow? Okay, you know, it's an update in a loop, and generally speaking, running updates in a loop is slow for SQL. So to say there's kind of common performance issues, every performance issue is unique, really, because there's lots of them. If you want to know more about reading execution plans, I've just been publishing some new videos on those, and I've got a performance series coming soon, so stay tuned for that. That's going to be really useful to help you understand how execution plans work and look in what you need to look for in there. I think the hierarchical profile and the profiler stuff Shashank's talked about is really useful to kind of go, okay, this SQL statement is the one that we need to start paying attention to and analyzing.
Here's a question, Chris, that I think is best for you that was directed to me. In production, we get an error like object being locked by another object. We query the locked objects, but it doesn't show any result. So in this case, how can we identify it in another way?
How can you identify it? If it's saying either if something's not appearing in the lock, then either by the time you've got to it, it's disappeared. It's something I've had an experience of. You've got blocking locks for some reason, and by the time you've realized it and someone's actually looked at it, the issue's resolved itself and it's kind of gone. In which case, you've got to look at enabling auditing or better tracing to capture things. But if it's genuinely not there, it's not in $V lock, it's not in DBA, DML, DDL locks, I think that's when you might need to start talking to support about. I don't know if Shashank's got any other ideas.
And I don't know if that answered the question because it was a little bit unclear there, but I've got some more questions, so should I keep going through them? Okay. And Shashank, I'm sorry. Was there more territory you were going to be covering, or should we spend the rest of the time in Q&A?
Actually, I can run the SQL DBMS hierarchical profile real quick. maybe I'll take maybe 5 minutes, and we can run the Q&A.
Let's do that, and
I think this might add more value. Yeah.
Okay, go ahead. So I will. So you can go ahead and share your screen, and
yeah, sure.
do that. So there's a question here. Can I set PL SQL profiling on a user level so that all calls in a session are logged? Well, when you turn on profiling, it's running. They want to know if you can turn on profiling for some other user.
You mean to say for another user in a sense?
In another session,
schema?
I assume.
Another session? It should be possible. Yeah, it should be possible. Only thing is, it's like we have to do some. See, it's all about the call is DBMS package, right? DBMS profiler is a package, so you can always plug this with any session we kind of want to use it against, right? So we can always have it at the top of a session call if that helps, right? So it captures the information. So it should be kind of a preceding call to a particular piece of code we are looking to debug, right? So it can be done.
All right, I'll let you get on with your demo, and I'll answer some questions quietly.
Yeah.
Before our hour is up.
Yeah. So now we saw about the SQL profiler, right? Very quickly, let me share another tool, right? So this is one more tool which you can add to your arsenal, right? So like Chris said, there is no kind of one solution fits all in any programming, even in PL SQL, right? So there are different scenarios where program might kind of fail or behave badly. So you need to have more weapons, right? This is what I believe in, right? AWR is a weapon for you. Explain plans is another weapon, or it's something which is very, very helpful, right? Explain plan. So then you have profiler, you have hierarchical profiler. You need to ensure that you are thinking in these 4 or 5 terms, right? At least at a higher level, to ensure that you are kind of covering all the pieces of it, right? So let me just use the same code, right? Whatever I had used earlier, and try to see how the hierarchical profile behaves now, right? So the prerequisite for this is, right, I need to have a directory created, right? So you are aware of DBA directories, right? So you always create a directory and you kind of point a particular path, right, in your Linux machine, which points to this particular directory. So prerequisite for this is to obviously have the execute privilege on DBMS hprof package, and you need to create a directory. So in this piece of code, which I'm sharing now, I have created the directory called PL SQL prof dir. If you want to know more about that, it points to one of the directories in my code. Oh, sorry, I should have shown DB underscore directories. Yeah, so it points to a particular path called as /dmp, right? So this is where I want this particular file to be created. So I create this as a part of this particular activity, right? So I have already created it. So now I'll execute the start profiling. So this is similar to what we saw earlier with profiler also, right? So this will start running that particular, it starts collecting the information. Now, after that, you run the actual procedure execution itself, right? So this, like you recall last time around, it took about a minute. So when this is running in the background, the profiler will collect the information for us. So let's give this about a minute. And we should stop it, right? Like, see, obviously I could have kind of merged all 3 of these and run in a block, right? So I just kind of split it. You can, opt to run it one after the other, right? There is no need for 2 or 3 anonymous blocks here. Just to make it simpler, I have this run it.
By the way, we've had a number of really interesting and questions coming in. Basically, I think when we show people things like the profiler and show things even like the PL SQL optimization, then the natural kinds of questions are, well, can't you just fix our program for us? I mean, if you can see where it's running slowly, can't you just fix it? And it's a lovely idea, also a very scary idea to think about asking the compiler or some automated mechanism to fix your code for you. But just so you know, when you compile your code, there's automatic optimization that goes on already. And the PL SQL compiler is really, really careful about making changes that it knows it can make that do not affect the intentional behavior of your code. You might look at a piece of code and say, I know what it's supposed to do, but that's a very hard thing for a compiler to automatically understand. So we can understand and apply certain optimizations, but to rewrite your logic in any substantial way is something that the compiler will never do because it can't guarantee a lack of side effects. Back to you, Shashank.
Yeah, so I have completed executing the hprof for the same procedure which we saw for the DBMS profiler. So there are two pieces for this also, right? Like I said, one is the data collection part of it, and the second is to go back and analyze the report we get from there, right? So we have done the data collection part of it, which will be running this profiler itself and executing the package or procedure which we want to kind of use the profiler against, right? So we have done this part. The second piece is to run a utility, right? There is one utility which we need to run called as PL SHProf, right? It's like PL kind of SHProf. I don't know, like it's like HProf is I think hierarchical prof. PLS is probably is the prefix for it, right? So we need to run it from one of our path, right? From DBA, I think it will be from bin directory, Oracle home and bin directory. We need to execute this particular thing. What this does is, whatever trace file we generated, right? If you look at it, what we got, we executed this particular piece of it, and we asked it to kind of create a trace file. So now that you have a trace file will be raw, right? So I'll just show you how that looks. So if you remember, like I created a directory and /dmp path, and this is a trace file it has generated for me, right? So hprof.trc. So now if you want to read it, yeah, you can obviously read it, right? So there are certain kind of conventions available for this also. PC means it will be calling a function, or R means returning. So there are certain things if you want to read, like if we have a lot of time to read every line and try to understand, we can obviously do. PL SQL documentation has good information on this if you want to interpret it, but we are lazy, right? Programmers, good programmers and good analyzers are lazy also, right? I would not say lazy in a bad way, right? So you don't want to check each line. You want certain output which kind of helps you out, right? So we need to kind of see how we can get an HTML out of it, right? So we will look at that step. So for this, like I said, I will run this utility called PLS HProf. So here I will be providing the output format I need, right? HTML output, and I'll be feeding it this particular trace file which we saw now. Yeah, see, it's so quick, right? It completed it, right? And it has already given me that information. So now regarding this PLH-prof, right? If in case it is not set in your particular database schema, you can go to the command line. There is a set of instruction to do this, right? It's simple. You need to log into that. DB server. You need to get into the Oracle home, get into bin directory, and run certain SQL file. It's part of the documentation. It's very simple to follow. So now I want to know whether it has written. Yeah, look at this now. So it has written. Yeah, if you ask me, has it written? Yes. So it has written a lot of HTML files. If you look at it, right, a lot of interesting HTML files. So now what are these HTML files, right? We'll check. So if you remember, the name we had used this was hprof.html. There was no need to use the HTML. I think suffix here. It is my habit to usually give, even in AWS, right? I give maybe performance.html. So even though it might be generating an HTML file, I have that habit of doing that. So it's a double HTML, at least the name of the file, right? So these are the files it has created. Let me FTP this for analysis. Yeah.
Sorry, so folks, we are running over the hour, but we should be done in a few minutes.
Let me quickly FTP them. So now, right, like I said, if you want to kind of analyze this kind of profiler outputs, right? It's like very user friendly, and it's very very easy to read. See, this is something you can always add to your performance debugging part of whatever tools you use, right? Because they are very user friendly and very and I would kind of say that this is one of the best kind of output you get, right? So let me go back to the same directory. Yeah, and I'll open the file which we are interested to see, which is hprof.html. So this is the profiler output for me, right? So this is the hierarchical profiler output. If you look at it, right, it gives a lot of data, right? Like if you want to understand more information which was not there in the profiler, that's why this complements the profiler, right? So you can always use the profiler, but if you want to drill down further and get more information, this you can put it as something which complements the profiler, right? So here you can see that it has taken about 68 seconds. It has given in microseconds. Usually, right, that is like even more useful information, right? Like I said, if your SLA is very tight, if you want to see and ensure that it runs in 5 seconds, for example, these are all the information which helps. So if I have to see this, I need to just click that particular output. This gives me the information, right? See, it gives at the subtree level. If you look at it, right, it tells me each line in this particular piece of code, right? So, and it has even given me the calls, right? How the calls have happened in this particular procedure. So this is something like a subtree level information, and it's also in microseconds, right? And if I want to see, for example, if you remember, I was talking about PL SQL and SQL engines, right? You can even get that here. Yeah, okay, this is one more, right? So here what it says, this is something like module elapsed time. So it tells that this particular module has taken maximum time, right? And it has, the second one is the second procedure, and then the third procedure, right? This is similar to the profiler output, right? The profiler also gives something similar, but this again gives me the number of calls also, right? Function calls. It's like it's all intrinsic functions, right? Like there are a lot of intrinsic functions. Each particular thing is treated as a cursor, right? It could be implicit cursors also. That information also you get. So even if you want to understand, right, like the parents and children elapsed time, right? So that also is available here. So it tells like what is the subtree, right? What is the parent, right? And then you have children, which is again set of procedures which are called inside that, right? So you can even drill down to this level. And
right.
Another feature, yeah.
That might be enough for this presentation. I hate to keep people on for too long.
Yeah, sure, Stephen.
Anything else besides running through the HProf report? Are you done?
Yeah, I am done with the HProf, Stephen. Actually, the thing is like, if I have to kind of just summarize that, right?
Yes.
You need to think through the use case, right? Whether it is a performance issue specific to a procedure. Always use profilers wisely, I would say, right? And it is something which is available freely, and it's part of Oracle licensing and all. There is no extra cost and all. And always look at the use case. If in case there are subcalls, right? There are multiple nested programs. Mm-hmm. You can opt for HProfiler. Otherwise, PL SQL profiler itself gives a lot of information, and it is enough in most of the scenarios.
All right. Thank you, Shashank. So I'm sorry that we're over time. Thanks for joining us and sticking with us. That was a really excellent presentation. Lots of great Q&A. We'll be publishing the slides afterwards. You can go to the Ask Tom Office Hours page for PL SQL and download the session details there. And if you want to find out more about performance analysis and tuning, especially of your SQL, do follow Chris R. Saxon on Twitter. He'll be releasing information about a brand new class soon on the DevGym on performance and new videos. Lots of great stuff. So thanks for joining us. And please, folks, do stay safe, stay healthy in this very turbulent world we live in today. Things are rough out there, but at least we have our software. Happy coding, everybody. Take care.
Thanks, Chris. Thanks, Stephen.
Thank you, Shashank, so much for doing this.
Thanks, everyone. Yeah.